Hello and welcome to the EduLect. This video is a part of lecture series of the topic called number system. In the last video, we learned about the types of numbers such as prime number, composite number, co-prime number and twin prime number. If you have not watched that video, I recommend you to watch that video first before moving next in this video. Link is in the description. In this video, we will continue our discussion from the next number in the list, that is rational number. Rational number is defined as the number which is in the form of p by q and q is not equal to 0 and p comma q belongs to integer are called rational number. So let's see some example. Number 11 upon 14, it is in the form of p by q and q is not equal to 0. So this is a rational number. Simply, number 9 by 11 is in the form of p by q, where p, 9 and 11 both belongs to integer and 11 is not equal to 0. So this is a rational number. Similarly, let's take another example, 8 upon 1, which is basically equal to 8, and here denominator is not equal to 0 and both 8 comma 1 belongs to integer. So this is also a rational number. Since the number have denominator, to divide the numerator, the division of the number can terminate after decimal places or may not terminate. So we can classify the rational number in the form of two types. There are two types of rational numbers. First is terminating rational number and second is non-terminating rational number. We will see that in a moment. So let's first see what is terminating rational number. Those rational number which form a terminating decimal expression called terminating rational number. Example, 1 upon 2 gives result 0.5 and it terminates after the first decimal places. So this is called as terminating rational numbers. Similarly, 3 upon 2 will give 1.5 and it terminates after the first decimal places. So this is a terminating rational numbers. Second type of rational number is non-terminating but repeating rational numbers. It is defined as those rational numbers which do not form a terminating decimal expression but a number or a set of number repeat periodically in the decimal expression are called non-terminating rational number. Let's see example. 10 upon 3 gives 3.33333 and it do not terminate. So this is a non-terminating but repeating rational number. That here number 3 after the first decimal places keeps repeating. So we can write 3 to the bar, that number 3 is keep repeating. Similarly, 11 upon 7 gives a result like 1.571428. This set keeps repeating itself. So we will write it as 1.571428, meaning this keeps repeating. Let's see, the next type of irrational numbers are defined as all those numbers which are not rational, called irrational numbers. It includes all the mathematical symbols, surds of the number. For example, pi and e known as epsilon, are the mathematical symbols. Similarly, root 2, root 3 and root 5. The value of pi is known up to these many digits and it do not terminate, and further we do not know what the value of this will be. So we have kept this in the category of irrational number. Also notice, in the mathematical calculation we often write pi as 22 upon 7, right? So it may be asked that whether 22 upon 7 is a rational number or irrational number. The answer would be it's a rational number because 22 upon 7 is in the form of p by q and p comma q, which is 22 comma 7, belongs to integer and q, which is basically equal to 7, is not equal to 0, right? so it's a rational number. And E is the Napier's constant. Similarly, so far we have known only up to 4 decimal places of the Napier's constant, so we have kept it as an irrational. We do not know whether it will terminate or not, so these are the irrational numbers. And also the surd or the square root of 2 is, it do not terminate at all, so the surds of a number are also irrational number. Let's see the next number, that is real number. It is defined as collection of all the rational numbers and irrational numbers are called real numbers. For example, -2 is a negative number and it's also a integer, right? And 0 is a even number, odd number, also whole number. 4 is a composite number and even number, right? And also a whole number, also a rational number. And pi is an irrational number. So the collection of rational and irrational number are called as real numbers. Let's see the next type of number, that is complex number. Complex number is defined as a number which is in the form of a plus bi, where a comma b belongs to R and I equal to a square root of -1 is called complex number. Here a is called as the real part, represented through RZ, and bi is the imaginary part. A complex number can be in 3 states. When b equal to 0, then imaginary part will be equal to 0. So that time number will be purely real. When a equal to 0, then real part of the number will be equal to 0. So this time number will be purely imaginary. And when b is not equal to 0, then it will be a complex number. Let's see the value of iota. Suppose you are given an equation a square plus 4 equal to 0. Then a square will be -4, and if we remove the square, it will be equal to plus minus 4. Then a can be written as plus minus of 4 into -1. Further, it can be written as a equal to plus minus of root 4 into root -1. So a can be written as plus minus of 2 and root -1, and a can be written as plus minus 2i, where I is equal to under root -1, called as iota. Let's see the summary of types of numbers through the tree diagram. So the very first number in the hierarchy can be the complex number. and it can be categorized into two types: purely imaginary number and real number. Purely imaginary number will be when a equal to 0, and real number will become when b equal to 0. Then again we have classified the real number into two types: irrational number and rational number. Then rational number is classified into two types: integer and fraction number. In case of integer, the denominator equal to 1, and the fractional number can be categorized into two subtypes: terminating decimal and non-terminating but repeating decimal numbers. Again, integer is categorized into two subtypes: negative numbers and whole number. And then whole number is categorized into two subtypes: 0 as well as the natural number. The natural number are of various types like even, odd, composite and prime number, and 0 is also an even number. So this picture helps us to remember the hierarchy as well as the relation between the different types of numbers. Let's see the summary of types of numbers through the Venn diagram. And here also all the natural numbers are of type whole number, and all the whole numbers are type of integers, and again all the integers are rational number, and all the rational number are real numbers, and all the real numbers are complex number. In the set format we write like natural number is a subset of whole number is a subset of integers, integer is a subset of rational number is a subset of real number, and real number is a subset of complex number.